the general measurement system, and we're going to go through some basic definitions. And if you have any questions about the lecture, please contact me on matthias@bota.no. First of all, let's define a system. A system has a clear border defining what it is and what is not a part of the system. So if you have here a car might be a system, and it's clear what's part of the car and what is not a part of the car. So for example, the road signs are not a part of the car, but the wheels, the steering wheel, the seats, everything is a part of the car. And even if we load the trunk with a lot of, say, heavy material, a lot of sand, for example, well, then that also becomes a part of the system, because the whole system will behave a bit differently when it's loaded with heavy sand. Changes to its response, that is the response of the car, are a result of the inputs that we send into the car and the system characteristics. And the example that I used earlier with the sand in the trunk, that changes the system characteristics. And as an input to this system, we have the steering wheel position, actually the angle of the steering wheel. We have the pedals that we put in, and also we have things like wind and such. Outputs from the car are, for example, position. That's what I use the car for. I use it to get from one position to another position. Along the way, I will have a direction, I will have a velocity, I will have acceleration, and they are all outputs from this system. Also here, if a system does not have inputs, it is not controlled. And if a system does not have outputs, it's a pointless system. So, if we don't have inputs here, well, how could we control the car? I control the car, the system, by the means of the inputs. And also, if it doesn't have outputs, I could give as many inputs as I like to the system, but it wouldn't change its outputs. Well, then that would be a really pointless system. A system may be made up of subsystems. So you can have a car which is made up of subsystems like the engine, the braking system, even the radio, and such. So everything here is, the whole system is a set of subsystems. And here is a YouTube film which is linked to in the presentation, the PowerPoint presentation, if that is available to you. It's really just a demonstration of a pointless system. Common measurement variables. Let's place myself up there. Typical inputs and outputs of variables to and from systems. Well, really, it is the whole SI system, really. You can have inputs here that are, for example, mass, kilograms. You can have input to a system that is position, meters, time, amount of substance, ampere, everything, and also you may have everything here which is combined measures like force, for example, pressure, frequency can be input to systems, and also the same elements here can be outputs from the system. So the system here may have, for example, electric charge as an output of the system. And it says here, a system that generates one or more of these variables is a process. So the system here is processing its inputs to give outputs if it's turned on. If it's turned off, you can give as many inputs you like. It will not process those inputs, and thus it won't provide outputs. The purpose of a measurement system is to convert the variables of the system to a convenient form. So that is the measurement system. A measurement system uses, for example, the input is the steering wheel position, and you want that to be used by the servo mechanism in the car. Well, you need a measurement system to measure the steering wheel angle or position in order to use it in the computer, which again serves the servo with its data. Tells the servo what to do. The same here, pedal position. You want to feed that to the engine, but it's in modern cars you actually go via an electric position detector feeding the engine with electrical data. In earlier days you simply had a wire connecting the pedal position to the opening valve in the combustor in the engine. Also velocity, that's interesting for me. I have a velocity meter in my car telling me what my velocity is, so I don't get fined for overspeeding. Acceleration, well, the ABS, the brake system, ABS, or the stability program also needs to know the acceleration, so that you have acceleration meters in the car, which is a measurement system. Position is provided to, for example, a digital map. And I have a lot more sensors and measurement systems in my car, for example, for temperature and everything. The elements of a measurement systems are these four. First of all, you have a sensing element. The sensing element converts the true value input into usually what is an electrical value. So for example, you might have heard of a PT100 temperature sensor or sensing element, temperature sensing element, or a strain gauge, which is a strain sensing element. So you have the real, for example, temperature out here, and you convert that to an electrical value. Typically that would be a resistance, a change in resistance, but not always, but usually it's a change in resistance in many cases. Now, you want the next step to be a signal conditioning element. You want to make your signal more suitable for the next step. So here you have things like resistance to voltage converter, because you had a change in resistance here, and that is not a very convenient measure, so you want to convert it to a voltage. Amplification, gain, to get it stronger, and everything to make your signal suitable for the next step here. It says here that in part of the signal processing element is the ADC, analog to digital converter. Well, that might also be a part of that element here. But still, the signal processing element, what that does is that you take the data here and you do calculations on it, for example, so you can convert a voltage here to a true value for a temperature, for example. And then you feed that to a presentation element that presents the data. An indicator, for example, a display, a gauge, but the data might also be presented to something that is not a human on the output side. You can present the data to the next step in a subsystem. So you have a measurement system that presents the data to, for example, a piston or something. Block diagram, typical block diagram and block diagram symbols. Block diagrams are used to simplify, to increase the understanding of the system. So we use these standard symbols here in order to make these block diagrams. So you have if you want to add, for example, two signals, you use that symbol and you have pluses added to it. Subtract that signal minus that signal, you simply have a plus and a minus sign. This symbol are sometimes also used in an electrical schematic diagram as a light, but in our block diagram it's an arithmetic point, so you do addition or subtraction in that point. If you want to multiply x multiplied by y, you illustrate that by a squared box. If you want to multiply by a constant, you simply put the constant here. So let's say that the constant is 5. So the input here goes through the 5 box to the output. So the output y is 5 times stronger than the x input. X is multiplied by 5 and then to the output. You may also have a function here. You can, for example, say here 4x plus 3. So you have x is multiplied by 4 times stronger, and then added 3. Integration, differentiation, we will come back to that later, on how these work in measurement systems.